Tamarai Selvi is working as a professor in the Department of Computer Technology, MIT campus of Anna University, Chennai. She has over 30 years of teaching experience. Grid computing, cloud computing, and e-learning are her areas of interest. She has successfully completed 12 research projects funded by Government of India and Tamil Nadu state government. She has established Center for Advanced Computing Research and Education and acquired 1 patent and has filed for 3 more patents in her research area. She has presented over 110 papers in international conferences and published 45 papers in international journals. She has authored 5 books. The latest book is titled Mastering Cloud Computing, published by Morgan Goffman Publishers 2013.
Welcome back to the UGC lecture series on computer science on the topic of cloud computing. So far we have discussed about the different types of computing evolved over a long period, and to understand the web service via SOAP and HTTP, how it is implemented, just I want to explain it. See, you are having the client side, that is, this is the actual client side system and this is the service side system. See, these are all the softwares we are having. In the client side, you are having the actual container in which you can have the web service engine available. You can develop the client code using Servlet or Enterprise Java Bean or some other code you can have. You can invoke the service which is available in the server. So, in both the sides you will be having web service engines available. The actual invocation is marshaled. Marshaled means it is converted into a SOAP request format. The invocation may be in any form. The actual marshalling process is taking place to convert it into a standard request called SOAP request. That SOAP request is again sent through the HTTP protocol, that is why it is called as HTTP request. Then again that SOAP request is unmarshaled here. That unmarshalling operation is nothing but decoding the marshaled data. Then it is invoking the actual operation to be performed. Once the operation is over, because that operation invocation is the actual function available in the server code. So, once the operation is over, the result is obtained. The result is known as the response. Again the response is marshaled, that is encoded, and it is converted into SOAP response. Then the SOAP response is sent through the HTTP protocol. The SOAP response is again unmarshaled and it is received at the client side. So, this is what is happening. Suppose if you just want to know the actual stock exchange price of an item, you are just invoking some request. Internally it is marshaled, that is encoded, it is converted into a SOAP request. Marshalling is meant for just converting the actual format into a generic format. This is sent through HTTP request. The operation is performed here, response is also sent back as SOAP response. So, we are having HTTP request as well as HTTP response whenever you implement the web service via SOAP request. By using the SOAP, simple object access protocol, we are able to implement the web services in this way. So, we can access the remote function or remote method which is available in some other computer by using these 3 ideas. First, you should know how to locate a computer which is available in the remote system. See, you are having one client system, another server system. The client system is going to access the server system. How to locate the server system? For that purpose, we are using the IP address. So, suppose if you are having www.annauniv.edu, that is an IP address. Actually, it is the URL, we call it as URI. IP address means it is the machine, unique machine address which is given in say 152.10.12.32 like that. So, IP address always mentions the computer's unique address through which the computer is identified. It identifies the actual computer. Then second one is URI. that is unique resource identification. Here only www.annaunu.edu, that is the URI used, that is that URI is equivalent to that IP which is mentioned by the name. Suppose if you are having google.com, that is the URI we are using, but wherever that particular server is available, that is represented by the IP address. So, the URI is mapped with the IP address, then only it is possible to locate a computer. Okay, it is easier to locate a computer. You have identified the URI also where it is possible to locate the web page which is representing your actual website. Suppose if you want to invoke a method or function available in a remote system, in that case you need socket and port. So, you establish the link by using the socket, and port is the address in which you are going to access the particular function. So, socket and port are the means for binding a method which is available in the remote location. So, to have the remote access, now we want IP address where the computer is located, that is how do you locate a computer? By using IP address. How do you locate a file? By using URI. How to bind to a method? By using socket and port. So, we are having the remote access in the distributed systems by having IP address, URI and socket and port. So, this is what we are having the web service implementation. Now, we have discussed about the basic requirements of this cloud computing excepting virtualization. I will discuss about the virtualization in the next class, but before coming to that virtualization, let us discuss about other fundamental or introduction part of the computing. Actually, when you see the trends in computing, first of all we started with cluster computing. When you think of cluster computing, you are having a group of computers connected together, and you will consider one as the master node and all other nodes as the cluster nodes. So, you are having worker nodes or clustering nodes. Now, in the cluster computing, all the n number of computers are working together, so that you will be getting the final output consolidated by the server node. The server node is the actual master node which will be controlling all other worker nodes. So, in the cluster computing you are having one server node and worker nodes. Worker nodes are many. Suppose if you are having 5 worker nodes and one server node, totally you are having 6 computing nodes. That server node will actually allocate the task in the distributed manner to all the 5 worker nodes. Once the 5 worker nodes complete the task, the result is taken out of the particular worker node and the server node will consolidate it. So, it is performing a parallel distributed task. So, cluster computing is one of the examples of this recent trends. Then from the cluster computing, we just developed grid computing. Actually, in case of grid computing, we want to have enormous computing power for certain applications such as weather forecasting, or you can have the CFD applications, computational fluid dynamics, or some satellite applications. Whenever you want very high end computing, in that case we are going for grid computing. Actually, in the grid computing, we are sharing resources, computing resources, memory resources, that is called as grid computing. You share the resources, so that instead of having one supercomputer being used for an application, you can use 5 supercomputers connected together, and the tasks are distributed in all 5 resources. Finally, you are getting the tasks completed. The next one is on demand computing. In case of on demand computing, the particular user is ready to pay whatever you want, but they will be having some sort of quality of services demanded by the persons. They are paying the amount with the demand of the quality of services required by the client. So, in on demand computing, we should provide the services as per the requirement of the customers or users. Then we have evolved with cloud computing. Actually, when you consider the cloud computing, here this is the concept of sharing of services. In case of grid computing, it was sharing of resources. Here it is sharing of services. Then utility computing, here it is like renting a computing machine. How many hours you are using the computers, based on that you can also pay for it. So, that is the concept of utility computing. So, we had got a different developments of the computing principles using cluster computing or grid computing or on demand computing or cloud computing, or you can have the utility computing. Tomorrow you may be having earth computing or universal computing. See, we can give different names, but starting from cluster computing only we have arrived at cloud computing also. Now, again I want to tell the same thing, that is over a period of time how the various business ability has been improved by having different types of computing. We started with mainframe computing. The mainframe computing, they were very much useful for financial applications, banking applications. Even some of the applications are run by mainframe computers, because it was having a very big investment and they had been proven to be the foolproof application. That is why people are still using mainframe computers. This is mainly for very big applications with a large number of customers. Then we had the personal computers, which are useful for small applications, we call it as PCs. Then we went to the client server architecture, and over the period of time internet was developed, and due to the technological development we had the service oriented architecture evolved, and using the service oriented architecture we were able to develop the web services, and then grid computing, network computing, utility computing, and now we are using the cloud computing. So, we are having different business driven web 2.0 virtualization. These are the various technologies that contributed to the development of the cloud computing. And when you consider the evolution of sharing on the internet, first we had the networking principles. In case of networking, we had the multiple regional networks linked together, and we had the universities and other national laboratories linked together by using the networking. So, we made use of it only for the educational institutions, that is called as networking. Then network sharing, in the network sharing, internetworking and the internet. Internetworking means you are networking across the different places, and we had the regional wise networking, and also we had the worldwide adoption for file transfer and all. So, we got the total networking used for sharing the content through internet. Then we had the information sharing. The information sharing is done through World Wide Web. Actually, World Wide Web is nothing but one web server which is having lot of files stored in it, and we can have the HTML files stored in the web server, so that you will be able to open all those HTML pages through browsers such as Mosaic or some other browser you can make use of. And the information sharing was done across the universities initially, then it had the worldwide adoption. Then we had the resource sharing. In case of resource sharing, we are using the concept of grid computing. This is also a distributed computing concept. Mainly they use the standards as well as the software for sharing of remote resources, and they had the collaboration also, and it was used for highly scalable high performance computing jobs. Then services sharing, that is called as cloud computing. So, everything is considered to be a service over the web. See, we are having software as a service, SaaS, utility computing, information technology services, and it is ubiquitous, it is always available, it is scalable, like that it is having enormous characteristics to add to this cloud computing. The main point we have to understand is grid computing is resource sharing, that high performance computing resources are shared across the globe, and the cloud computing is services sharing, anything is shared as a service. Say for example, you can have the travel agents, we are getting the travel services through travel agent, we are having so many brokers, the brokers are doing their job to help you to get the things done. Suppose if you are having the retail traders, they are using the various opportunities to get the market driven opportunities. Like that, we are having different types of agents. The agents will help you to link the service provider with the service user. That is the concept we are using in every day to day activities. The similar concept has also been extended for this cloud computing. That is why we call it as services sharing. So, cloud computing means you should remember that it is services sharing. So, let us have a small break and we can continue later. Welcome back to this cloud computing lecture series. Now, let us consider how the cloud computing was evolved. We had lot of other computing evolved over a period of time. See, we had the client server computing, then peer to peer computing, distributed computing, collaborative computing and then cloud computing. Already discussed with other on demand, utility, grid, everything we have discussed. This is also another name used for the similar type of computing. First, if you consider the client server computing, here you are having one big end server available and you are having number of clients connected to that big end server. The application as well as storage is centralized. In the big server, you are having the application stored in it and also the entire data is stored in the server. The clients will be having minimum processing capability. You will be sending the actual request or sending small amount of data and you will be getting the output to this client. So, this is the client server computing concept. You are having the various clients available in distributed location and the server is located in a centralized place and all the applications, all the data, all the software, everything is available only in this server. So, this is called as client server computing. Next, the implementation of client server computing, if you see, we are having the client. In the client machine, you will be having the World Wide Web browser, that may be Internet Explorer or Firefox or Mosaic browser, anything you can have, and through the browser only the client is interacting. Actually, behind the screen the underlying protocol is HTTP. The HTTP in turn uses TCP and the request is sent through the TCP protocol and the HTTP is actually having this port address also. Port address is the actual address through which the particular service is recognized or read, and then you are having the World Wide Web server. Apache server is an example of the server. So, you are requesting through the browser and internally it is going through HTTP and TCP. Again at the server machine you are having TCP, HTTP and the server is giving the actual data requested by the browser and you are sending back. So, the request is sent through the header, that is http://cs. You would have seen on the address of the browser where you can see the actual URL, that is the HTML file. You want to get this particular HTML file to be downloaded from this web server. Now, the response is the actual file HTML contents is given back through this one. See, we will be seeing only the browser part, that is in the system you will be seeing the display over the browser. The HTML file is actually interpreted and you will be getting the content displayed on the web browser. So, this is the client server implementation. The client is available in one location, server is available in some other location. Then peer to peer computing. Here you are trying to share the resources. The difference between the client server computing and peer to peer computing is there is no centralized controlling authority. Here each computer is having equal sharing. See, the particular computer can be acting as a client as well as server. That is what we call it as peer to peer computing. This may contact this computer, this may contact this computer, all the computers are connected together. Whenever one computer fails, automatically it will be routed through some other computer and you can reach the other computer. So, the peer to peer computing is having equal responsibility for all the resources available in it, whereas in the client server means the server is the authority which will be controlling all other client programs, as well as it will be providing the services which is centralized in the server. So, this is the actual peer to peer computing resource. Then you are having the distributed computing. The simple example for distributed computing is grid computing. You are having number of computers available throughout the globe and all the computers are connected together to provide more computing power. The actual task is distributed across the different resources. The inputs are also given from different laptops or any other client machines. What we want is the client is submitting the job to the particular system, but it will in turn contact another server where it will identify the facilities available in all the systems, and this client request can be handled by these three servers, means it will allocate this job to these three servers. Suppose the request from this particular client is solved only by any one of these four or by combining all these four, means this server will allocate for this one. Actually, this is acting as a resource broker, right. This broker will identify the suitable resource in which the task given to the particular broker is done by this one. For the client, he or she does not know where the job is executed. They do not know these are the various computers connected to this broker. They simply submit the job. It is the actual task of the resource broker to identify the suitable resource in which the task submitted by the client is actually executed. So, this is the distributed computing which provides more computing power. Next one is you are having the collaborative computing. For some of the applications, it requires sharing of various people for completing the task. See, this is one example. You are having different documents, calendars, survey and voting, then you are having the different committees, you are having the tasks and projects, internet. So, everything is shared. So, collaborative means to complete one task, we want to fix a meeting on such and such date. So, that calendar is useful for fixing the date and everyone will say yes, I am available on that date. What are the documents you want to share? That can be shared by having these documents. Then if you want to have some voting or you want to know how many are giving the opinion about that particular task, that can be obtained. So, in a collaborative manner, many users are jointly working together and that is called as collaborative computing. For example, in medical applications, it is possible to have the doctor available in US or UK and doctor available in India. Both of them can collaboratively do the operation. They can have the various records of the patients to be shared among the doctors. The doctor can see the actual X-ray report, actual investigation reports, and he will suggest this may be the solution for this particular disease, or you can perform the operation in this way. Like that, we can get the remote access of the experts by using this collaborative computing also. See, there are lot of advantages for this collaborative computing, and grid computing is also making use of some of the collaborative computing, because some of the inputs are scanned and it has to be sent to the computing side and it will perform the operation, and then it will go to some other machine where it is sorted out. There some operations are completed and it will be going to some other thing. So, collaborative problem solving can also be achieved by using collaborative computing. Next, cloud computing. See, we have evolved through different types of computing, but all the types of computing are in one way or other distributed computing only. So, in case of cloud computing, if you see, we are using the different entities connected by network. See, you are having router which will be helpful for routing the information across the printer, across your mobile device, across your tablets, iPads, whatever it may be. Then you are having the switches which is useful for networking different components or devices, and you are having everything available in the cloud. See, actually the name cloud was given because normally we use the diagram that cloud, the internet is represented by the diagram cloud. That is why we are using the name cloud computing to represent internet is being used for doing the cloud computing. That is the reason we are using the name cloud. And in case of this cloud computing, you are having number of servers available in different locations. You can have the virtual desktop. Virtual desktop means actual machine will be available in the server, but you will be viewing that server in your mobile device or in your iPad or in your notepad. So, that is why we are having the virtual desktop created, and that OS is simply seen through your devices. You can have the software platform, that software is available in some other machine, but your computer will be reflecting only the output displayed through that software. Similarly, you can have different applications available in the cloud, different storage media available in the cloud, so that the data can be stored in that place. See, you would have seen the iCloud. iCloud means that Apple is having that iPhone, then your iPad and your PC. All those three can be synchronized using iCloud. Whatever you are editing in the iPhone will be updated into your laptop as well as to your iPad, because the actual storage required for the usage is given in the cloud. So, whenever you have the internet access, laptop or your iPad or your iCloud, all those things will be accessing only the common storage which is shared by your laptop or iPhone or your iPad. That is the reason we call it as iCloud. Like that, everybody is trying to bring the thing so that the synchronization is needed. We are having plenty of memory available in the data centers. The data center is having big number of storage devices as well as computing devices. You can imagine the number of servers, number of storage units available in one data center equivalent to a big university campus. They maintain the entire resources in a single place. You are making use of the virtualization concept, and you get the portion of the computing resources or storage resources or some applications or any platform, whatever you want, you can take it from cloud. So, that is the main advantage. You are not the owner of the actual resources, you are having it. Whenever you want to access it, simply you should provide the internet connection. Through internet, you are simply accessing to the cloud and you are getting the access. So, the minimum requirement is you should have one portable device in which you can have the browser opening. Once if you have the internet connection, you are able to do anything whatever you want. So, this is the basic concept of cloud computing. So, to summarize, we have discussed what is a web service and also what are the various limitations the web services can overcome, that also we have discussed, and we have discussed about the actual data flow in case of the deployment of any web services, and we have discussed how the remote system is accessed and also the actual implementation used for the remote access using the URL and also socket and port. Then we have discussed about the various trends in computing, how the cloud computing was evolved, that also we have discussed. For the purpose of understanding, the students may be able to answer the following questions. What is the evolution of cloud computing? What are the service models in cloud computing? What are the deployment models used in cloud computing? What are the various applications you can think of using cloud computing? So, if you are able to answer the questions, you may be able to revise the concepts which we have discussed in this episode. Thank you.